This scrape on the neutral, this scrape on the live here. Found it. There's a tiny little pinch, which was pinched on the bottom of that. Right there, can you see a burn mark right here? There it is. Found it. Last day of the year and we are here at Emergency in Bristol. Let me show you what we are going to deal with today. It's a bit freezing. This is a new property for my customer. It is a fuse box. It's been installed this year. It looks like this is a brand new installation. 2025, July, signed off for 10 years. Customer said there's no power in the kitchen. Well, that lifts up very easily. What we're gonna do is take the fuse board cover off, remove the cables and do the insulation resistance test just to see if either one of the appliances could have failed this. And what we have in the kitchen, whereas the lights are working, it looks like a brand new kitchen as well. We've got sockets, a switch for a dishwasher, socket, that's a washing machine, no boiler, no extractor, another socket, there's no appliances here. We've got oven, but I imagine oven will work because it's on a separate circuit. It seems like a brand new house, and that is the question, because why would someone on a newly rewire would do something like that? I wonder what that is. The fan doesn't appear to be working, and the fridge freezer obviously is not on as well at the moment. There is no dedicated isolation switch for the extractor fan. I literally just arrived. Last day of 2025. We've got a socket. This appears to be a spur. Whatever that switch is for, it is appeared to be working, so it's still, again, it's off lights. But that may be spurred, but if it's extended, it should have two cables. We'll double check. There's nothing that appears to be connected apart from this, as it is obviously plugged in, maybe hardwired, maybe not. Okay, it's switched off up there, okay? It doesn't ventilate anywhere. I've got carbon filters in. Let's grab some of the gear to open it up. The installation can tell you a lot before you even start doing anything with it. Let me tell you what I'm seeing. It's a brand new rewire property. You can tell there's a smoke alarm, paperwork from the fuse board. What do we have? We've got an isolation switch, new meter, 60 amp fuse only for the property of this size, okay? We've got new 25mm tails, which is good. Someone did complete a label, but they didn't put the installation date. That's not much of a problem. The cables are quite largely exposed, as in the copper when it's terminated inside. Turn off the power to everything. We are only interested with that 32 amp circuit, which has more than two cables in. So firstly, what I'm going to do is I will show you my new addition for testing gear. It's like this super rod to magnetic link. It's brilliant, and I'll show you how much this saves me time when I have to do insulation resistance tests. Get my machine, plug the leads in, crocodile clip on the green one. This thing goes in here. Let me set insulation resistance test, turn it on. So currently, just everything else is turned off. I'm doing like almost a global insulation resistance test on everything here. All the parallel paths for earth, because I'm not actually removing the earths now. You can see that this little device, one of the legs is slightly longer because it's designed for RCD testing. The short one goes into neutral, the long one goes into the live. So that's how they design. Let's hit 250. We know the extractor fan is still connected into the system. First installation resistance test, 1507. Okay, 7 mega, 6 mega ohms. It's jumping around, crazy. Let me hold this just to make sure that this is not the fault of the magnet. No, it's not. Jumps around. For an installation that is only a couple of months old, this is unacceptable. I wonder what this could be. I'm going to open this up, remove the cables, both from the neutrals, neutral life, and also earths. At this point, we want to test to make sure that this is only that ring alone, and nothing else. You're almost like a Sherlock Holmes. Let me show you what I'm seeing. Do you see those two cables? They both bent the same way, so it looks like this is the ring. I'm expecting this to be the ring. And this is an addition cable. It's coming from the right-hand side. I'm gonna pull these up this way. That looks like a spur. We'll find out what it is in a moment. Let's focus on the kitchen ring. That was pretty loose, actually. Okay, I think they use an impact driver because this is a slotted screwdriver, which is other people call flat. If I pushed in and I don't have a really nice and sharp edge to turn, that means someone used an impact driver and that impact driver damaged the screw inside. Not good, don't do that, people. I know this socket looks beautiful with these two fellas in, but look what I have to do in order to open this up. Sometimes you can get this, just like I did now. On many other occasions, I just have to push it in and damage it. But with a sharp blade, you can just remove those little white blanking plates. I'm gonna do two things now. First one is to split installation into two. Second one, identify my legs of the ring. On the fuse board, I will mark which leg is which. Let me show you how I'm gonna do that. By grabbing three-way Wago, clipping them all together, then I will know exactly which neutral and live and earth goes together. So this is a resistance test with audio feed on, so if I touch them, it will give me this. So if I grab that live with this earth, it's nothing. Let's try that one. No. So that's not this earth I've clipped into the Wago. Let's try this one. No. And that one. Yes. Cool. That earth goes with this live and this neutral, and that one goes on that side. Okay, we've got it. So that's one side of the ring, that's the other side of the ring, and that's what I wanted to achieve just by putting that Wago on. And now, essentially, we've got two radials, one side and what it should be second side. One of them should give me a bad reading, or maybe I'll get a bad reading from this fella here. I'm taking both of them to speed up the process. 250, well, I can actually do 500, even if something is still plugged in. This is the test that I'm performing, both live and neutral to earth, which even at 500 volts, I shouldn't be able to damage anything. If I get 999, which is the highest, again, not bad. You can see it's going up. Let's just accept that is all right. I would like to see 999. I wonder if there's a certificate, which should be, what insulation resistance test for a ring circuit was when it was installed first. Let's test this side of the ring. 25, 26. Much lower, as you can see. Much lower. It's going up 32, 33. The minimum acceptable would be 2 mega ohms, but I wouldn't expect to see 2 mega ohms on a brand new install. Bum, bum. Yeah, that's what I should see on a brand new cable, greater than 999 mega ohms. Whatever that does, it's absolutely fine. So actually the problem is somewhere on the ring. This side gives us much lower reading than that one. Now is the time when we will look back on that cable and now individually. Earth and live. That 20 something mega ohms, if I do live to earth, if it's higher, it means that's where the problem is. 34, well, it was in that area, so no greater improvement. Let's just confirm to neutral. 999 to neutral, fine. We're looking for that low resistance issue to live, not to neutral. Let's individually check the other side of the ring. This is the fault that is intermittent, because when I came in, I did flip the switch and it stayed on. So this is not a fault that is easy to trace. 150, 160, 70, 180, 90, it's slowly going up. I think the longer I keep holding, it will start rising. So let's just go individually to neutral. 999. Good. Allow me to show you one more thing. How do we check if there is a load, if there's something still plugged in that I'm missed, that I don't see? If I do neutral to live at 250, again, you don't want to go higher than that because the voltage goes up to 250 volts. So if there's still a load, I will have 0, basically dead short. Okay, so on that side of the leg nothing is connected between live and neutral. There's no load sitting. Let's try this one. Nothing again, which is good because I've disconnected this stuff. I show you what I mean. If I reduce this to 100 volts, and I will put these two on. And that will show you. Let's try this one first. It may not see them because you still have to put an on and off button on the actual washing machine or a dishwasher. Yeah, 999, that's fine. So, and essentially again, it's almost like the pad test, but without them being switched on. Someone has to go then and keep the button on. 103, that's interesting because it has dropped down. What I'm going to do is I will now attempt to actually remove the appliances and turn them off from the sockets.
A few moments later.
Let's now reconfirm these tests. Live and neutral to earth. Okay. The reading is still fluctuating. That's the problem. I fear there might be a bad connection at the socket. Yeah, we're still where we were in 30s, but it's jumping 50, 40, 60, 80, 70. Yeah, this is not easy to find because I'm getting the high readings. This is actually an interesting find. Okie dokie. I think this used to be a thermostat of some sort and is just being now changed. Maybe boiler was here before. I think that's what this is. An old thermostat programmer. Not our concern. So I want to now break the installation in the other part and have a few sockets that hopefully will give me a perfect reading and a few sockets that would be not perfect. Look at this. You wouldn't want to find something like that on a brand new install, isn't it? Was that an original, an extended, and something happened? What a chance that I've opened that socket and not this one, for example, yeah? Interesting, even though that fella was nearly out. Let's try to figure this out. So a brand new ring that had to be extended. The cable that was coming down originally, it went into this block, and then they've added... The fuse board is higher up, so the cables naturally would have to drop down to every socket because that's what you would do. That's what I would do. So now seeing cables coming down from the bottom, I think this is what has served the purpose over the rest of this installation. It's only an assumption, but I think it's a pretty good one. Let's open this up so we get a good understanding of what is what. And I think this was the last socket. So it was kind of a new install, but what did they do? Oh, the screw terminal, and it's tiny as well. Why haven't you used Wago? And I don't think these are even rated to 32 amps. What the hell? These are not rated to 32 amps. These are tiny. I think they are maybe 10, 15, or even maybe 16. I don't know. I don't use them, so I'm not really familiar with how well they rate it. If you want to slag me off for that, please do. But we only use Wagos because we know we can rely on them, and they're maintenance free. I cut myself. I better go and put a plaster on that thing.
One eternity later.
Okay, we're back. I think I'm gonna live. Stab myself with a knife, so that's how these knives are not safe. If we had Wagos in here, we wouldn't have that. So that's not normal on a brand new rewire. So someone just messed up and obviously they had to change this. Okay, cool. Let's try now and see if we get a bad result again or if we get much improved results. Right here, installation resistance. We are on one side. We're not checking that cable. I think that cable is completely separate. 999, it's beautiful. That's what we want. So now the reading is perfect. Let's go onto that side now. Let's see if it's the same. 230, look how rapidly it's going up. It's much better to what it was before. Great. If we want to drill down just to see where it is between which conductors. So now earth to neutral is 999. Earth to live is just less than perfect, basically. Less than perfect. That's what it is. It's not bad, it's less than perfect. That is not bad. That's quite high readings now. Some tester only tests up until 200 mega ohms. This is a really great piece of kit. What I've just basically found out is the cable, as I disconnected the mid part, is good. We now need to drill it down and see where it is. It could be even a screw, a bloody screw going through a cable. First things first, I want to find out which that leg is there. So if I go to resistance tests with the audio feed on, come here, touch, neutral, and live, I know which leg it is. I guess that one? No. Try this one? No. Try that one? No. Let's try this one. Same again. That one. No. That one. Yes. Okay. Let's use professional labeling. So if we take this number 1 and we put it on that one, and we take number 1 and put it on the leg that we're testing, now we know this is 1. Let's go onto this one. And again, if we connect two cables, we'll have an audio feed. So again, that's it. All right. That's number 2. And let's put 2 on here. Okay, that's 2. I'm doing this because it's not easy and I need to keep track of it because I will be doing a lot of different tests as well. So I just want to make sure I know what I've tested, I know what is good. And I show you why do I do that. Because right now, this moment, I'm going to put Wago on live and earth. Just to test the continuity, I'll leave my tester there. I'll just grab this continuity tester. When 2 of these are attached, they give me an audio feed. That's all I need. So we are now testing. I'll make this really easy for you to understand. We are now want to find out where number 1 is actually going. So is number 1 going in here? Yes, it is. So it's also doing the extractor fan. Let's keep a track of it. Number 1. That's it. That's number 1. It's number 1 doing a fridge socket. Yes, it is. Great stuff. So we know the fridge socket, the socket near the cooker is fine. Again, this is just a reference for myself. Let's check if these 2 outside are served by number 1. They are. On that one, they are as well. When I go over to do other tests in a moment, I want to make sure that I'm not double testing the sockets I've already tested. And this is just helping me make sure that if I find something else and I have to go back on my steps, I want to be absolute sure. Yeah, both of them, that's fine. 1 label was enough. So this leg, what I've already found out, it comes from here, it goes outside, it does the extractor hood, socket, fridge socket, and it lands in the fuse board. Great. Now, this fella, we need to strip that a little bit more. Team will find, and it works very well. Now let's put live and earth. Okay. So I show you just a proof that this number 1 is no longer going to work. Yep, cool. So that should give us a feed to the dishwasher. Ah, no, it goes here. It does not. This is interesting. So it's not doing that socket. It's not doing this socket. That actually might be the cable, the first cable from the fuse board. At this point, what we're going to do is we will measure the exact resistance. So we've done number 1, and now we're going to do number 2. Let's make sure that we will take the resistance of the cables by doing that. 18, 17. 0.27 of an ohm. So we've got a Wago that's clipped in and we're measuring earth to live. 0.30. So this is the resistance, R1 and R2 values. 2.5 and 1.5, this is the cable that we are using. And if it's a 1 meter, that's the expected resistance, 0.3. So about 15 meters of that cable would be used to achieve 0.30 of an ohm. 15 meters? I don't think so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Give or take, maybe. So maybe there is actually 15 meters coming up here because I don't know how the cables, what route is going through the loft and how it's actually going. I know it's coming from the top. We've got one leg of the ring. Now we need to find out where all this shebang is going. We no longer going to do any tests from the fuse board because we got first original cable going to that far socket, second cable, which is serving these sockets, outside sockets in a lean-to. So we've got a second leg. Now what we are going to do is we're going to find out that leg, which one of them is that cable. Insulation resistance test. So again, live and neutral. Let's put audio feed on and let's touch the... Nope. Has to be this one. Yeah. I'm going to mark this as 3 for my reference, and then we're going to find out what is the other cable doing, where are they going, what purpose they are serving. I grab my Wago and I clip number 3. I'm also doing labels for you if you want to in the comments reference any, what would you do different? Maybe you've got a different way, better way than mine. And what I want to do now is test if number 3 also serves this sockets. So just a quick reference, that's all we do. No, they do not. Does it do that one? No, it does not. This is a link between live and earth. Live and earth. It doesn't serve any of these sockets. It doesn't do this one, it doesn't do that one. It's, at this point, I'm assuming that this is just a simple link between here and there. And how can I check that? Well, let's do a resistance test, yes? I cannot imagine this being a long. So, 0.17 ohms. If we go by the list, 2.5, 1.5, 17, it will be between 5 and 10 meters. Let's say half will be about 7.5 meters, let's say. If we assume 1, 2, 3, 4, 5, 6, 7, that's about it. So we know that this cable doesn't serve anything, okay? From this point on, that's number 2 going to fuse board, and that's number 1 going to fuse board. Number 3 between them, these were the 2 original sockets, I say, but plus all of that. And then, look, ladies and gents, we've left with these cables. If I were to put my Wago, it would give me continuity to these fellas. Look at this, surely. Yep, and yep. If I have to guess, someone did the installation and completely forgot about these 2 sockets and these 2 sockets. And they obviously just, from this socket, they've spliced it, extended the ring, and did these 2. Well, plus the load sockets. To confirm my theory, if I do end-to-end live and live, it will be a ring. Let's do that. So, live. Yep, 12, 11, same should be on a neutral. 12, okay. It's the problem how sockets are being terminated. I think that might be an insulation that has been clipped together with the cable. We know without these 1, 2, 3, 4, 5, 6, the installation is good. So this addition has introduced a fault. We are only now testing 1, 2, 3, 4, 5, 6, and we can absolutely be sure that nothing is connected. Let's just double check. There's no cooker sockets, nothing. Okay, go to insulation resistance test, 500, live to earth. Yeah, quite. Can you see that? It's fluctuating. We're going to open these up and find out. Earth to neutral, 999.
A few moments later.
And check if the top of the cables are not damaged. So it looks like the actual spur are not within the ring. They are being spurred from the ring, single cable into a spur and then down. There's nothing against that. It's just a lot more cables in 25mm box behind the socket. Not ideal. I'm just checking if the top of the cables are not being pinched by that. Same again. Not that I can see anything straight away. Let's continue on that path and see if this will improve from 40 mega ohms just by removing the faceplates. No, it does not. Maybe before I even open it up, because I said it could be the screws. Oh, have you noticed? It jumped. I think bingo. Look at this neutral, slightly damaged. That is also slightly scraped. It's not as much, okay? Let's do a test again. 999. That was it. That was it. We found it. Let's look in closer. This is what we're looking at. This scrape on the neutral. This scrape on the live here. Where else? Is that here? That pinch? Yes. Yes. Found it. Do you see here? there's a tiny little pinch, which was pinched on the bottom of that. Right there, can you see a burn mark right here? There it is. Found it. Damn, I'm good.
That's why he's the GOAT! The GOAT!
Before we install boxes, usually I ask my guys to put these flaps flat because they are not needed. We're always using Skolmore clip because it's easy to clip, but that's what it was. Look guys, they've just clipped the cables. The fuse isolation switch has 3 cables, so you have to be more tidy, but only 25mm box. You lazy buggers. Should be a deeper box, more room for the switch. Be more careful with the cables. To fix this, open it up, put a brand new sleeve on it, and making sure it's all good. Put everything back into the ring, retest, making sure everything is perfect, and that's it. Thermal sleeving, so if I put it on with the blowtorch, it will shrink. What I'm going to do is I'll firstly put the sockets together, retest before I close them up, making sure everything is just as I want, ideal, and then do the test from the fuse board. I will spare you this. See you soon.